Hi. The last time we talked, we mostly focused on the algebraic process to get through these equations. What we're going to look at today is specifically how to get through them using images to illustrate the process. Part of our goal in this early unit is to get a very good foundation in the algebraic skills we're going to use later. To this end, we're going to be working slowly through less problems and doing a very good job of explaining every step in them. This is why we're going to be working in 3 columns. We're going to have one column for the algebra, starting here with the problem. We're going to have one column for words, describing what we're doing. And we're going to have a third column for the illustrations, the pictures of what's happening as we work our way down. So let's begin this problem using this idea. First we have our problem itself. You can write down in your notes, x plus 3 equals 7. From there, we're now going to go to the next step and draw the illustration to it. So I'm going to draw a box with x in it. I'm going to draw next to that 3 positive circles. This represents the plus 3. Now when a positive circle and a negative circle collide, they cancel. Now this is going to balance on a scale with 7. X plus 3, this part, equals 7. This side of the scale balances this side. So that means over here, 1, 2, 3, 4, 5, 6, 7. Now the advantage is you can use multiplication to make these easier to draw with larger numbers. Because you can make a grid of them and you can get a pretty good number packed in there. So, I now have my illustration and I have my original equation. What I'm going to do now is I'm going to work algebra over here and I can illustrate what's happening on this side. So, I'm going to subtract 3 from both sides of the equation. Now depending on how you learned your sign numbers, you might think of this as adding a negative 3 to both sides. And that works just as well. When I come to my scale, I'm going to be taking 3 items off each side of the scale. So I will be taking these 3 and throwing them away. Likewise, I'm taking these 3 and throwing them away. So algebraically, what's left? X plus 3 minus 3 becomes simply x. 7 minus 3 becomes 4. Illustration. If I have x and 3 circles, I take 3 circles away, I'm left with the box that contains the x. What's balancing that? Well, over here, I had 7 circles. I took 3 away. I'm left with 4. I've now balanced my equation. In terms of language, what's happening on this step? I'm subtracting 3 from both sides. So in the middle space, I'm going to write that I have subtracted 3 from both sides. That's what's happening on this middle step. The last thing I need to do is check my answer. So what I'm going to do is plug in 4 for x and see if that's really true. 4 plus 3 is 7. And that checks out. Now I can illustrate this check also. If I go back to my original picture, instead of having an x, what if I draw 4 circles in that box? So that means if I use my original illustration, I have x and 3, so I have my box which is x, which contains 4 circles. Then I have 3 more circles next to it. And then I have my 7. So when I look, I can see that 7 circles over here will balance 7 circles over here. So illustration-wise, I can show that the scale remains balanced. Word-wise, I'm going to write when x equals 4, the equation x plus 3 equals 7 is true. The ultimate goal of algebra is to show that when you substitute a number back in, you make a true statement. And that's what every step of the algebra is intended to represent. Take a moment now and look at your notes and compare them with mine here on the board to make sure you have a match. Check your algebra, your language, and your illustrations to be sure that not only do they match my work, but they make sense. Remember, the illustrations show that we're keeping a scale balanced as we work our way down. All right, we'll take a look at another example, maybe a third, and then we'll be ready to tackle a few on our own.